Welcome, my name is David Reynolds, and this presentation is on electric vehicle charging in the United States. This is for Johns Hopkins University for the Spatial Databases and Data Interoperability course. All right, let's jump into the presentation overview. I'll give an introduction on myself. We've got the who, what, when, where, why, and how, but not necessarily in that order. So after my introduction, we'll go into the topic of the project, the data sources that were collected to perform the analysis, the initial proposal, and then what happened in real life, the data itself, the transformation tools that were used, as well as the ArcGIS tools that were used. And then at the end, you'll have a link to the actual web map and the application that was created. I'll go through a few lessons learned and some future research to do after this course, and then give a few acknowledgments. All right, a little bit about myself. My name is David Reynolds. I go by DCR. I am a student in the Master's in Geographic Information Systems program at Johns Hopkins University. I have a background in finance, risk management, banking, and I used to run a small business. I live in Charlotte, North Carolina. I'm born and raised here. And I've traveled pretty extensively. I'm only missing Antarctica from a continent's perspective, and the picture of the sunrise over Rabbit Island from Oahu from a few years ago. And I'm a recent electric vehicle purchaser. So a little bit about the why. I recently purchased an Audi Q8 e-tron, which for those of you that are interested, you can play this lovely commercial here that gives a little bit of overview of the car. It's a lot of fun. I've had an Audi in the past, an internal combustion Audi. They're always a lot of fun, but it was getting a little old, so I said, you know what? Let's see what the all-electric is like. And so that sort of informed and led me down this path of thinking about the electric vehicle charging infrastructure for this project. Those of you may already know, as a part of this program, that a lot of states have fairly aggressive emission standards through 2030, California being the most stringent, to where they are trying to get very low emissions or zero emissions for all light vehicle duty cars by 2030. One of the hindrances to electric vehicle adoption in the United States, through some of the research that I've done, is just the fast charging infrastructure as a whole. There's not a ton of fast charging stations that are non-Tesla, and that lack of fast charging across the country for long haul trips and otherwise has kept some people from not purchasing a fully electric vehicle. So as a part of all that, I wanted to see if there were open data sources that could compare where the current infrastructure existed and where is the additional infrastructure going to need to be placed based on the typical demographic of who is buying electric vehicles right now. So where did the data come from? The first data set that I gathered was from the National Renewable Energy Laboratory, which is a subset of the Department of Energy. They have an alternative fuels locator that is updated nearly every day that you can download the specific electric vehicle charging stations. It also houses other charging type stations, whether it be for hydrogen or other types of fuels. Uh, just for the electric vehicle stations, there are approximately 65,000 in the United States. All that data does contain latitude and longitude data. It includes public and private facilities. And then each of those stations is going to have a number of ports, whether it be the level 1, which is the lowest level of charge, level 2, which is more like a dryer plug, a little bit faster charge, and then the newer and less frequent, the fast DC charging stations. So those are the three different types of electric vehicle charging stations that are within that data set. The next set of data is from the U.S. Census. The U.S. Census has a very extensive site where you can download data for days if you really wanted to. The specific data sets that I was focused on were from the American Community Survey of 5-year estimates. So there are subsets of data within the American Community Survey that can be downloaded at the tract level. So each of those survey results can be applied to different geographies, but I really wanted it at the tract level, and there are approximately 81,000 U.S. Census tracts, and each of those contains a GeoID called a Federal Information Processing Series, or a FIPS code. So each table has a different number of variables linked to them. But the 5 types of variables that I really wanted to focus on were income, commute patterns, electricity cost, race, and sex. So for the what of the initial proposal that was submitted for the midterm for this class, this is sort of the outline of the FME workflow of what I wanted to build for this overarching project. I really wanted to build some additional models within ArcGIS Pro to allow users to sort of toggle some of the views of where some of these electric vehicle charging stations were. Also wanted to create an HTTP caller back to the National Renewable Energy Lab site to where that data would be updated, and also to explore some of the application programming interfaces to the U.S. Census website. Since a lot of that data that's within the U.S. Census is in a very structured format as far as the naming of some of the fields and the tables that are out there, so I felt like the use of APIs would be pretty useful with that data set. Also wanted to get into some proximity analysis at the tract level to see if there were a certain number of electric vehicle stations within certain types of tracts throughout the United States. And then, very similar to what I did in a previous class, which if you guys are interested in census information and haven't taken the course already within this program, there is a course offered in the summer that is a census data and visualization course that is quite powerful. But originally wanted to look at specific metro areas, so this was the original proposal. So regarding the how, the 2 different data sets that I had, the charging data, not really too unwieldy. It's in a CSV format downloaded from the National Renewable Energy Lab website. I was able to create point geometry pretty easily with the latitude and longitude information. The census data, on the other hand, is always a different animal. Each table, since it's at the census tract level, has over 80,000 rows in it. The statistics that I was looking to present within my map had not been calculated, and there were numerous fields that were just not needed for what type of analysis I was looking to do. So I knew attribute management was going to be crucial for putting this information together. Also, the formatting of the FIPS codes in and of themselves to create the join to the actual shapefile that contains all of the tract information was fairly challenging. There was a lot of troubleshooting in figuring out which fields needed to be converted to either a text or a number format to be able to create that join so that all of my calculated statistics could be enriched to the tract level within my map. So just an example of what some of the fields and the field structures look like within the census data. So each field, the beginning here, you'll see B25132, which is one of the specific tables that comes out of the American Community Survey data. And then the subset being either an E, an EA, or an M, meaning an estimate, an annotation of the estimate, or the margin of error. As these specific variables at the tract level are not actual numbers, they are statistical projections using 5-year estimates from a sample of these American community surveys that are sent out. There's hundreds of thousands that are responded to every year, and then these variables are based on those responses using statistical analysis. So a lot of these fields that I didn't need I knew that the functionality within FME would allow me to keep some of those, but with my lack of awareness of how to use FME going into the semester, I did end up using Excel quite a bit to sort of manually carve out and do key field searches on which data elements and attributes I really wanted to keep, and also needing to calculate a lot of the statistics that I wanted to view in my map and have additional symbology within my maps at the tract level. So manually creating some of those percentages as each of those numbers and the estimates were at the tract level. So having to go through and create some of those was very manual. But despite having a lot of those manual workarounds within Excel, I was still able to utilize FME to help out with pulling together all of the various attributes that I wanted to see in one specific view and export to a geodatabase table that I could then import into ArcGIS Pro for a project. So I had 5 different CSV files as different readers. And then I was able to use different renamers for different fields and some of those details to take out some of the items that just were not necessary for what I was looking for. And then I was able to pull all those together with an aggregator and then take out some of the characters that I knew would be a problem in ArcGIS before they were written to my geodatabase table. So as you can see on the far right, it was quite a few fields that were pulled together and different percentages that were calculated in my manual Excel file that I wanted to make sure were available for users to apply symbology in an application or a web map for some of the different demographic characteristics of an electric vehicle purchaser. So once I had all of my files written to my geodatabase table from FME, I was able to upload that to a new project file within ArcGIS Pro. So I had a few more things to do from a data cleanup perspective. I needed to figure out my joins. Once I did have my statistics fields that had percentages calculated from my geodatabase table, I didn't figure out a clean way to make sure that those were presenting as percentages, so I did have to go through and manually change the number formats within ArcGIS Pro when I was doing that, which did take quite a bit of time. But as the information started coming together and I did more reading on the actual topic, I wanted to focus more on the fast charging infrastructure because although the number of fast charging stations will not outpace some of the level 2 charging that will be either at home charging or workplace charging, the percentage numbers of stations will not nearly be what the level 2s are, but they will provide roughly half of the energy that is given to electric vehicles and the projections that I've been reading. So really wanted to focus on that, and the fast charging and the lack of existing infrastructure is one of the biggest barriers to consumers purchasing full electric vehicles versus hybrids and other internal combustion cars. So wanted to see if there was a way to visualize where some of that infrastructure gap is across the country and within the existing transportation network. So that's what I wanted to focus on. So this is just a preliminary view before the data was exported to a web map. And you'll see that I end up creating buffers around different types of charging stations, especially the fast chargers. So the blues are specifically charging stations that are not on the Tesla network and have 8 or more actual ports at each station. And the reason I was trying to focus on 8 or more is just based on the consumer experience and the driver experience, thinking about the number of chargers that I've driven to with my new car, and knowing that if there's only maybe 3 or 4 ports, Right now, some of those chargers, they're either broken or they're already occupied. So really trying to focus on where's the infrastructure where there are more than 8 ports, which is very similar to a gasoline station where you pull up to the pump and there's multiple pumps. So trying to see what that infrastructure looks like in comparison, and just seeing the differences between the Tesla network and the non-Tesla network. When I started this research and building out this map, it had not been announced yet, but there are more and more manufacturers that are reaching agreements with Tesla to leverage their network and to have specific adapters that will use their charging stations. Now, that might not be great news for existing Tesla owners, because that means other car companies and other users of non-Tesla vehicles will be at those Tesla charging stations. But I think for the overall adoption and meeting some of these emission standards across various states, I think that will help, since the non-Tesla networks are just not as prevalent throughout the United States. So once I had added a lot of my layers and different symbology within ArcGIS Pro, I was ready to share it as a web map so that I could then use that as the basis for other applications. And in the past, I've had similar error messages like this, but well, warnings rather, not necessarily errors, but I definitely did not heed these warnings. There were certain fields that were not supported that I overlooked. However, when I first published my initial web map and I troubleshot through field maps and was able to see that on my mobile device in field maps that there were lots of JSON errors, and so I went back and was able to look at some of those data elements, and there were certain date fields and one large integer field that needed to be recreated and saved down to a different type of format. So I was able to go back and do that, and then republish my web map. And there's specific tools within the data engineering functions. If you look at the bottom left, there was a date last confirmed that originally was a date only data type that was not supported, and that needed to be basically recreated in a new field as just a date data type instead of a date only data type. So then once I fixed all of those field elements and got rid of all of my warnings, I republished and was able to not have those errors. And so this specific web map contains all the layers from ArcGIS Pro. It has additional tagging where folks can search for things like Tesla and electric vehicle charging stations, things like that within the profile of this. And also enabled group sharing so that anyone can view the map and look at the different layers. But once I got here and wanted to create my web app, I wanted to think about what really is the goal of what the web app was going to look like, who the audience was going to be, and also what kind of devices were the users going to be accessing the application from. So I ended up going with a web app builder. And I think that was going to give me the best functionality, considering that other dashboards that I've used in the past were just not the similar format that I wanted. And as much as I love story maps, I really wanted something that people could really dive into, export data from, add data to if they wanted to. So that's what I ended up choosing. So this is just a view of the published page for the electric vehicle charging stations and census analysis application for the web mapping application. And what is included in this are some specific widgets where there are set filters to apply to specific demographic information. Users will have the ability to import other data sets if they like on top of this data set. They can also select either using rectangles, polygons, or circles and export the feature data sets from that if they'd like, and can do additional analysis on that. Also included a swipe widget so that people could see the difference between some of the Tesla versus non-Tesla network, and really see how Tesla is currently dominating the electric vehicle fast charging infrastructure market. So the win is now. You can get involved by getting into this application, digging through some of the details, seeing how some of the filters work, how some of the widgets work, and really would love to hear y'all's feedback. What are your observations? Would you have used different widgets? Did you end up adding any data to the application? What data would you take out? Seeing what you see as a part of these data sets, were there other sort of Esri tools that you would have used to build another type of application? I would really love to hear from y'all. My email is there if you have any feedback. And yeah, I hope you guys enjoy the actual application. I know I really enjoyed building this, and I'm really actually pretty happy with the final product, although we'll get into some of the lessons learned on the next slide, but I do like the look and feel of how these specific widgets look. It's a pretty clean view of how to export things, and seemingly pretty easy to import additional data sets as well. So just to touch on a few lessons learned and to talk about some future research. So coming into this course, I did not have any experience with FME, and I think even with the limited instances of how I used it within this particular project, I did find it very helpful in completing some of the other assignments that we had throughout the semester, and just gaining some additional familiarity and comfort with that is huge. So really looking forward to taking that with me after this course. And then APIs, I know that was a relatively newer topic towards the end of the semester, and was not successful in implementing that as a part of this workflow, but definitely got more comfortable with that. Formatting was huge, and thinking about troubleshooting things and potentially trying to clean up some of those warnings before publishing, I think was a huge lesson learned. Focusing on specific demographic information. I think a lot of the layers that I have in my app and in my other web map, they're not as critical, and they can bog down the application when you're trying to look at 80,000 census tracts. So trying to hone in on specifics, or maybe filtering some of those before you apply to the broader application. Some things I'd like to look at in the future are some of the proximity analysis, with looking at what's really the sweet spot for the number of electric vehicles versus the number of fast charging stations. Are there certain metropolitan areas that have a better mix of home charging versus at work charging versus fast charging to go to different regions? So I think that would be a really interesting thing to look at, as well as looking at the range that continues to increase with the newer models of electric vehicles, and the formation of solid state batteries. I know that that's been a huge topic that's come up in my readings for this project, and looking at some of the materials and where those materials are coming from a supply chain perspective, going into the 2030s, and where and how all these components are going to be built. The other thing to consider is the real estate transition. What I mean by that is, if there is going to be this massive adoption of electric vehicles in the United States going forward, what will happen, or what will be the opportunities for some of the gas stations that are currently out there that will eventually become obsolete? Thinking about potential sites that would be contaminated from tank leaks, or how could those be repurposed within each of the communities that have a larger portion of these gas stations that will need to be repurposed once they become obsolete. Just a few quick acknowledgments for the U.S. Census, the Department of Energy, as well as links to the actual web map and the web app that were created as a part of this project. So just wanted to provide those for anyone who is interested. And just a huge thank you to the whole class for taking time to sit through this presentation and to listen to me. A big thank you to Dr. Stepanov, who just took a lot of time and creating materials and answering questions throughout the semester. I was able to spend some time in office hours and just really appreciate the insights and the encouragement throughout this semester. It's been a really great course, and just really thank everyone for all of the detail and the effort that you guys put into your final products and your analysis. I'm not a GIS practitioner by trade, so getting to learn from y'all is one of my favorite parts of this program and these courses. So just really, truly appreciate everyone's final projects, and I hope you enjoyed what I was able to put together. Thank you so much.